take me some time. So I'm going to explain why dry electrode it can allow lower the cost. I need to make sure that I can flip the slides. So you can still see the slides, right? Hello?
Yes.
Okay. So this is a quick overview for AN batteries. So AN batteries, we have invented a dry electrostatic spray technology. So we do processing development. We also develop our equipment for lithium battery production. And based on our cost analysis, we found the dry electrode AMB technology, we can enable 45% energy consumption, 30% of capex saving, and 5 times equipment footprint. Again, my name is Wang, and I'm the co-founder of and the president of AN Batteries. This is my second startup company. So the other company I co-founded is Ascent Elements. They are doing lithium battery recycling. So in addition to that, I'm also a professor at Worcester Polytechnic Institute. So right now, our CEO is Li Shi, who was the president of Salgard, the major separated company before joining AMB last year. We also have Hu Dong as the chief manufacturing officer, who was the inventor of Tesla and Maxwell dry coating technologies. So in the last 3 years, we have raised over $60 million from TTK Ventures, Total Ventures, Posh Ventures, RA Capital, some major investors in the field. And again, the battery technology is not easy. So it takes years to develop and commercialize the battery technologies. So I started working on the dry electrode technology from 2013. So in the initial 7-8 years, mainly fundamental research from the university. So only after Tesla acquired Maxwell in 2019, and also Tesla announced the dry electrode program in 2020 in their battery day. So then I sensed the timing is here. Then I start raising the money. I raised $5.5 million in 2021. Then we deliver some initial samples to some customers. We quickly developed our technology pilot line. Then in 2022, I raised $25 million Series A. We signed some major JDAs with battery manufacturers and also materials manufacturers. And we also expand our senior executive team. So I recruit Li as the CEO and Hugh as the chief manufacturing officer. So last October, we just closed $30 million, which is led by Total Ventures. This year, we move into the new facility. We also develop our engineer pilot line. It's a pretty big pilot line. So why cost is so important for battery industry? This is a few reasons I came up because first thing is battery industry is a low margin business. So you can never expect making batteries. You can have a high margin, make lots of monies. And actually, many of the EV battery companies, they are not making money. They are losing money actually. So although the margin is not is low, but however, to set up a competitive battery factories in terms of the scale, you need billions of dollars. To give you some number, typically in the U.S., and you need probably $100 to $150 million per gigawatt hour capacity for battery plants. And these days, in order to have loads of compatible certain scale of battery plants, you probably need a 10 gigawatt hour or 20 gigawatt hour. Lots of companies announce 30 gigawatt hour plants. You times the $100 million per gigawatt hour to $150 million per gigawatt hour, you can easily come up to number at least $1, 2, $3 billion. And although in the university, when we make lots of small coin cells, it's easy. The entry bar is low. But however, making high quality batteries with a high yield is hard. So if your yield is not high enough, so your cost will high. But also making batteries involve many different steps and also many different materials. So if you only have certain materials or certain manufacture step give you some advantage, quickly if you do the battery manufacture, you quickly just lose all the advantage because those large like battery manufacturers, they can have much bigger power, bargain power in terms of the cost for the manufacturer and the materials. So that's why like making batteries is not easy. And however, like but industry they are always looking for lower cost solutions in terms of lower cost materials and lower cost manufacturing. So whatever you can lower the cost without sacrificing the quality, will put you in a much better position. So like we also did some analysis on the manufacture cost and the energy consumption. Again, in today's cell manufacture, still the materials is cost more. And for example, cathode materials is typically 50% of battery cost. But however, like we also did some like the analysis. We want to see like in the manufacture like a process, what steps contribute the highest cost and also highest energy. So from the figure, you can see like the slurry mixing, drying, coating, solvent recovery. Let's associate with slurry coating technologies. Let's current like the technology to make a battery electrode, no matter is LG Energy Solutions, CATL, SK-On, or Panasonic. And they contribute roughly 30% of manufacture cost. On the right-hand side is energy consumption. So for the energy consumption, those drying and solvent recovery, they can also contribute roughly 47% of energy consumption in the entire battery manufacturers. So that means if you want to lower the cost, lower the energy consumption for the battery manufacturers, you have to see what steps contribute the most. So based on our like research, the slurry coating is one of the major bottlenecks. So then this is a conventional like the figure. That's the conventional the technology how people are making battery electrode. It's all like called slurry coating technology. It's all from the mixing side. You know, basically you mix the cathode powder or anode powder with a conductive carbon plus like a binder solution. So after you make those slurry, you do the slurry coating onto the current collector. So because you have a slurry, you have solvents, then you have to dry it. And after drying, you have to do the solvent recovery because those NMP solvents you cannot emit to the air. And then you try to reuse those solvents. Actually, in many battery startup companies, they cannot recycle those solvents. Basically, they just collect those solvents, then send those solvents to the chemical waste companies, let them to handle the solvents. And if you ever go to like the real battery manufacturers, those drying oven and solvent recovery equipment, they are huge equipment, and they can be 100 meters long, a few meters high. It's less big equipment. And again, drying and solvent recovery, they account for 47% of energy consumption, 30% of manufacturer cost, and $66 million for 5 gigawatt hour plant, 1/3 of manufacturer floor space, and Europe, they are start tightening the restriction and the permitting on the solvent NMP. So basically, my main message is solvent-based electrode production is very energy and capital-intensive step in the battery manufacture. Then what is the AMB's solution? You know, in the past like 11 years, we have been working on solvent-free electrode manufacture. That means we don't use any solvents in the entire battery electrode manufacture. So that means we do the dry powder mixing. So after we do the dry powder mixing, we can direct spray those dry mix powder onto the current collector. Then we do the hot rolling steps. So that's it. So basically just do the like a dry powder mixing, dry powder spray, and dry powder calendaring. So we can remove the oven drying, remove the solvent recovery, and also remove the vacuum drying after the slitting process. We can basically reduce the electrode manufacture steps process from 7 steps to 4 steps. And this is we use Argon National Labs backpack model to do the cost analysis for 5 gigawatt hour plant. Again, 5 gigawatt hour plant is a very small battery plant these days. Initially, a few years ago, that's a good size of a plant, but now people are talking about 10, 20, 30. Anyway, based on those analysis, we found like if a company using AMB technology, they can save 47% of just energy consumption. That means like because we don't need drying, we don't need solvent recovery. That's a 47% of energy consumption. We can also reduce 41% of coating equipment because we don't need the drying oven, we don't need the solvent recovery equipment. We can potentially make a battery electrode thicker to increase the energy density of the cell and also reduce the inactive materials. So that means we can reduce the materials cost by 24%. Again, as I said like before, like the battery market is a low margin business. And you can never imagine expect to have 30% of margin for making batteries. And however, using AMB technology, we can enable a battery company to lower the cost to 5 to 7% without like additional with additional saving from like a thicker electrode. So like if you combine all those factors together, we can potentially allow the cell manufacturer to lower 10% of cost. So that means like if a dry electrode manufacturer technology is successful, all the battery manufacturer, they have to switch eventually because otherwise their cost will not be competitive. So this is AMB, like we call it the technology pilot line. It's a small pilot line. We have a bigger pilot line now. So we can using, this is our coating chamber, and this is our calendar equipment. You can see in the middle, that's a dry coated electrode, and on the right hand side is a calendar electrode. So like just a dry powder mixing, dry powder spray, and the dry powder calendaring. By adjusting the calendaring temperature and pressure, we can enable like the different process. By the way, we use all the commercial materials for making such a dry electrodes. And in terms of electrode performance, like on the left-hand side, that's the cycle life. Basically, we charge and discharge the batteries. And in order to do the fair comparison, we use the same materials, same composition, same loading, same process. The only difference is one is the slurry coating electrode, like the light blue lines. The dark blue lines is the dry coated electrode made by AMB. So you can see like using the AMB dry electrode, we can not only enable lower cost, we can also enable the better performance in terms of longer cycle life. On the right hand side, that's like the dry electrode and the slurry coated electrode show the similar rate performance. That means basically we charge and discharge the batteries at different series. And 1C means like you charge and discharge at 1 hour. And imagine like if like on the top of the figure, that's the slurry coating equipment. Again, if you see the entire coating line, so you see like the majority of the line is occupied by the drying system, by the solvent recovery system. That's 100 meters long. And if we remove those drying system and the solvent recovery system, we can reduce the line from 100 meters to 20 meters, because we don't need a dryer, we don't need a solvent recovery equipment. On the right-hand side, we did some analysis for conventional 30 gigawatt hour plant, how much money we can save. For example, we can save about like almost $70 million in annual energy consumption and $172 million one-time capital expenses, and we only need 25% of plant space. So like in terms of AMB's business model, like we want to supply the turnkey dry electrode coating equipment to the cell manufacturers. So we are not going to make batteries because again, making batteries is not easy and you need a lot of equipment. and lots of investment, and also different materials, different manufacturer steps. So we have the advantage of we only have the advantage of electrode manufacturer steps. That means so we are going to sell our equipment, the turnkey dry electrode coating equipment. We also doing the customer service, and we can also potential licensing our IPs. So to the cell manufacturers while they are buying AMB equipment. So AMB, we would love to offer the solution to many cell manufacturers. So I think that's all I want to share today. Thank you very much. So any questions? I'm going to stop sharing. Maybe I'm just sharing the screen. Yeah. So any questions?
Yeah, and I have a question for you.
Sure.
Porter Mitchell here. I'm well familiar with dry processing electrode technology.
Yeah.
Having worked with Hugh at Maxwell.
Oh, you work with Hugh, right?
Yeah.
Okay, I see.
I started doing the dry battery technology in 2004.
Okay.
The question for you is, how do you make the sale to someone who's already invested for wet battery technology, wet slurry? It's one of the things that we ran into. How do you go in and convince them that essentially they abandon that technology in lieu of the dry electrode technology?
So yeah, like a Potter, that's a good question. Actually we are working with most of the tier 1 cell manufacturers and also car manufacturers right now. So once they come to AMB to see our equipment, they are quickly convinced AMB equipment is the future. But that does not mean they will abandon their slurry coating equipment, because they already invest billions of dollars. I don't think they will just abandon their equipment right now. But what we are thinking, based on the discussion with them, so in the initially because many of those cell manufacturers they are still expanding the capacity. So based on our understanding, so initially those cell manufacturers they will use AMB technology in the greenfield. So in their new capacities, new plants, and some of them they already designed their plants based on the AMB technology. So that's initially. And once those technology is fully demonstrated and they see the benefits, they see the saving, I think eventually they have to change. But again, initially, I think they will install AMB technology in their greenfield, in the new capacity, new plants. They will not abandon their current facility.
Yeah, thank you.
Yeah.
I have another question if no one else does.
Yeah.
One of the things I know that Hugh and I talked about a long time.
Yeah.
Dry electrode technology is the technology for solid state batteries. Is AMB applying you're applying your technology to also the solid state electrodes?
Yeah, we are working with a company doing some JDA work on the solid state batteries. But again, so right now the major market for us is still conventional lithium batteries, because we don't know whether solid state batteries will be here in 5 years or in 10 years, in 30 years. So that's why our major market today is still trying to convince conventional lithium battery manufacturers to use AMB technology. But in the meantime, we are doing some research with some battery companies try to use AMB technology for their solid state battery companies. So I don't expect that they can order AMB production scale equipment soon.
Hey, can you guys hear me?
Yeah.
Hey, so this is Kevin Barry from Ateo Systems. We work on I would say, complementary technology to what you guys are deploying with the solvent-free battery electrode manufacturing process. I just had a few questions about kind of approach, hopefully not kind of overstepping, see if you can give me any additional information.
Yeah.
With respect to production line speed, so, this is something that we really focus on, and our approach is, like I said, I think there's a lot of actually overlap, and we can maybe learn a lot from each other through some further conversations. So if you're interested, potentially connecting after this, there might be some
Sure.
kind of points of conversation. But something that we really look at as we're scaling up through a toll manufacturing model is looking at production line speed and making sure that our solvent-free manufacturing process is on par with the existing slurry cast solution. And so can you give any insight as to how the production line speed for your dry process compares to the slurry cast process? Not sure if did we lose him?
I think we lost him.
Which is interesting because his slides are still up. Let's see if we get him back in here in a second.
Well, he is a professor, so he's probably familiar with the 15-minute rule. I don't know if we have 15 minutes left.
It was supposed to be a 40-minute session, right?
Yes.
Let's see if we can get him back.
Kevin, I can give you a little bit of information on there.
So can you hear me now?
Yeah, I can hear
Oh,
you.
yeah, there you go. You dropped off for a minute.
Yep.
Oh, sorry. So again, so in the conventional slurry coating technology is already pretty advanced. People can do like a 50 meter per minute. They are pushing to 75, 100 meter per minute. So it's very advanced. So right now, so for the dry coating technology, when we talk to cell manufacturers, we have to reach the comparable speed, as a slurry coating technology. At least that's the AMB target. Because otherwise, it's just if we can only reach 20, 30, it's just hard. I don't think we can convince those tier 1 cell manufacturers to switch. Because otherwise, it's not economic feasible for them.
Yeah, no, that's completely in line with our experience as well. So yeah, thank you for that insight.
Yeah.
A few slides back when you were showing the comparison between performance on the dry versus wet.
Yeah.
I don't know if you can go back there, but you had a percentage below, I think, one of the slides or at the bottom that one exactly. That slurry is 84% and dry is 90%. I'm sorry if I missed that. Did you explain what that was, what that difference was?
Oh, that's just like a capacity retention. So basically, we cycle.
I see.
Yeah.
And it's obvious.
700 cycles. Yeah.
It's obvious from the slide. I didn't know if that was because I've got the formulation bug in my mind, so I'm like, oh, does that mean it's 84% on the slurry side for the active material? Why the
no.
Okay.
Nobody will use those formulations.
Yeah, no, they won't. They won't. Okay.
Yeah.
Okay. Well, yeah. Thank you for the information.
No problem.
Yeah, and I've got a question about just the kind of general process and inputs into your cathode making process. Do you require any different raw materials or processing of those materials as an input to your dry cathode process versus kind of the cathode powders, binders, other materials that are going into the slurry cast?
So right now, all our materials, it's just a commercial available large quantity of materials. So that does not mean we don't have requirements for the materials. So imagine in the slurry coating, you dissolve the binder into the solution. Maybe you don't care too much about particle size, morphology. But for us, because it's dry mixing, so if we have those big particles, big PVD like a binder particles. There's no way we can just cover the entire the old active materials. So that means we do have some requirements, but but what I want to say is all the materials what we are using is all the commercial available materials. But we are still working with some materials company for to do some joint development research to find what's the best materials for those dry electrode. Because again, right now all the battery materials, no matter is active materials, binder, carbon, binder or conductive carbon, it's all optimized for slurry coating. Nobody, I think not many company has optimized their materials for dry coating yet. I think there's an opportunity for materials company play a big role in the dry electrode coating space.
Thank you.
Yeah.
So one other question that I had, you had mentioned, kind of with respect to the cell manufacturers not necessarily, immediately adopting, you had said that, hey, they'll probably maintain their slurry casting as well. They've already made the big capital investment there, which makes sense. Can you speak to the kind of uptime, right, or the required time for if they need to purchase new equipment? Because I think, if you're doing dry mixing, does that require new equipment? They have to make new capital investment to be able to facilitate that. And kind of tied to that question, with respect to the cost, right? So you had mentioned, and this is similar to our analysis as well, right? Going through that drying and solvent recovery, that is the most expensive portion of the step. So if you can eliminate that, I think that there's probably other technologies that are kind of competing with probably what we both have, right, with respect to that solvent recovery and trying to eliminate that. But if you're just kind of shifting the energy footprint to the mixing, and that's a question I've been asked a few different times. So do you have anything to say with respect to that? Are you really going to be more cost competitive if you have to invest in new equipment for doing the mixing? And then if you're doing like a high shear mixed, is that less costly actually than doing the drying?
So first thing, our mixing is much simpler. I know many people when talk about dry mixing or dry electrode manufacturer is mainly to refer to what Tesla Maxwell is doing. They need a high shear mixing for a few hours. That's a lot of energy. But for us, it's we need much less time for mixing. It's not energy intensive steps. But again, if you want to convince any cell manufacturers to scrap their slurry coating equipment, I don't think anyone will do it right now. So nobody will do it because again, they invest billions of dollars. They expect those equipment can be used 10, 15, 20 years. But I think our strategy is working with those cell manufacturers who are willing to expand their capacity, or even new companies who are design their capacity early, and they have to put MB technology in their roadmap, in their facilities early, because otherwise it's just for big capital purchasing, it's not easy.
Yeah. No, that makes sense. Thank you for that. Thank you for that insight.
Yeah. Any other questions?
Hi, Ian. My name is Jonathan Pistorino. My company's name is Valexian. We're a graphene encapsulation company that focuses on cathode active materials. And I just have a question about your full cell data depicted here. In your process, are you able to increase the active material loading up to what is commonly used in manufacturing? And several customers that we've spoken with, they're using 96% active material and even higher than this in order to improve energy density of their cells. And so this is something I'm not very familiar with dry coating or your process. Yeah. This is something that I know can be an issue with dry coating because you have to have essentially perfect electronic distribution, electronic conductive additive distribution.
So in those in the figure I showed right now, that's for both cathode and anode, our active materials is all 96%, 96 weight percent. Again, like if we only have like those 90%, nobody will use it. So those data is from 96 weight percent of active materials.
Oh, fantastic.
Yeah, we can push this one to 97 or 98.
Yeah. Okay, my apologies. I joined the meeting a little bit late. What are the percentages listed underneath your full cell data? Slurry and dry.
That's the capacity retention after 700 cycles.
Oh, apologies. I misread. Thank you very much.
Yeah. Maybe I shouldn't put there.
I had the same.
Okay. No. I think it was my mistake. I joined late. Thank you for explaining.
Yeah. No problem. So any other questions?
You'd mentioned that your strategy is to license, and you mean license the whole process, right? Really enable these tier 1 manufacturers. So I guess, that kind of is start to finish the whole thing, right? The mixing procedure, and the approach for doing that, the spray coating procedure, and then the resulting calendaring all in line, right?
No, our main business model is sell the turnkey dry electrode coating equipment. That's our main business model. And while they buy the AMB equipment, we can also potentially licensing our processing IP and know-how to them.
Okay. Thank you for that clarification.
Yeah. No problem.
One more quick question. Can you share the cathode active material grade that is used in this full cell data that's depicted here?
This one's the cathode materials we use NCM 622. The anode is graphite.
62. Okay, thank you. Very good.
Yeah, because what we are MB is MB technology is manufacturer technology, is chemistry like a agnostic approach. We almost tried all the chemistry.
Yeah, that makes sense. Great, thank you.
Yeah.
I think one last one from me. If you can share, you had mentioned that you can enable very thick coatings as well. Any comments on the loading for what you show on the slide here?
This loading is I think 20 to 30 milligram per centimeter square. So in terms of if we convert to the capacity, that's 3.5 to 5 milliampere per centimeter square. So 5 is I know is already high end for the conventional lithium battery electrode. So 3.5 is a regular electrodes.
Thank you.
Yeah.
Do you have any difficulty in matching the press density of a standard electrode at those loadings?
No. So I think actually we can get a higher press density easier than the conventional slurry coating conventional slurry coating.